So we're asked to revolve around the y-axis, so I pulled up the formula derived by our text when we're revolving around the y-axis. It's supposed to be with respect to y. So we can divide 6 from both sides, and then we can take the 4th root of both sides. That solves for x. So that's going to be our g of y. So we need to take the derivative of g of y, so that's 1 over 24 times y. Yeah, I'm doing too many steps at once. Okay, so the 1/4 comes down. Power gets reduced by 1. And then we multiply by the derivative of the innermost function. So that's 1, 6, 12, it's 1 over 24, 1 over 24. And then this is, if you're going to have this term to the negative 3/4 power, that's the same thing as having this term in the bottom. And then having it to the 4th root in the top, and I'll show you why. Because if the bases are the same, the power subtracts. So if you got a 1/4 subtracted by a 1, it makes negative 3/4. So this is a representation of this up here. Okay, that's our function, getting x by itself. That's the derivative, isn't it? That's the derivative of x. Take a derivative. So that's what we need to plug in here. But I can already tell this integral isn't going to work. This is going to be really complicated. G of y is going to be the 4th root over here, which is fine. And then the derivative is going to be squared, so it's going to get rid of that. That's still going to be really complicated. I guess we could try it, but I'm pretty sure this is one of those. WebAssign randomly generates these questions. The textbook wrote some questions so that you could do the integral. It just worked out nicely. But they're saying use your calculator to approximate it. For this question, you can go ahead and use online technology. So I've had this website pulled up. I just Google search. What did I type in? It doesn't show up. I typed in surface area calculator calculus. And this one just lets you replace. We want this to be a function of y. And our function that we got when we rewrote was y over 6 to the 1/4. I mean, otherwise, if you want to do this with a TI, you'd have to plug in this for your derivative, plug in this in for g of y, and then plug in 0 to 1 for your limits of integration. It's a lot of tedious calculation. And that's already from x equals 0 to x equals 1. So we need different limits of integration. If you plug in x equals 0, we need it in terms of y. So if you plug in 0, you get 0 for y. If you plug in x as 1, you get y as 6. So this is from 0 to 6 in our calculator, revolving around the y-axis. Let's check out the steps. Yeah, and see, look, they're using some sort of change of variables using like calculus 2 content that we usually do. And this is, I think that's that F, is that a 4-year series transformation? It's crazy, all right? So you can't do this with our normal methods. So 30.0